Microplastics are everywhere. Particles of micro and nanoplastics are tiny plastic fragments that have become new inhabitants of our planet. Wind and precipitation carry microplastics even to the most remote corners of the Earth. They're everywhere. From the highest point, Mount Everest, to the deepest Mariana Trench. The entire world ocean is saturated with microplastics. Every drop of ocean water contains these tiny plastic particles. As water evaporates, microplastics rise into the atmosphere from the ocean's surface and can be carried by the wind across the entire planet. They also become part of the sea breeze we breathe. Each year, approximately 136,000 metric tons of microplastics are blown on shore by the sea breeze. Now, when we swim in the ocean, sunbathe on the beach, or jog along the shore in an effort to stay healthy, we're only increasing the impact of microplastics on our bodies. Micro and nanoplastics rising from the surface of oceans and seas are dispersed throughout the atmosphere. Forests, like sponges, absorb them. Poor ventilation beneath dense forest canopies leads to a constant buildup of these particles in the treetops. Unlike forests, cities have good airflow, and the air doesn't stagnate. Additionally, heavier suspensions from vehicle exhaust and industrial smog partially settle micro and nanoplastics. The air in forests is far more dangerous to human health than in megacities due to an excess of nanoplastics. Research has shown that over 14 months, more than 1,000 tons of plastic particles fell with precipitation in 11 national parks and reserves in the western United States, enough to produce 120 million plastic bottles. A similar situation is observed in other countries. The Quercus serrata forests of Japan trap approximately 420 trillion airborne microplastics per year in their canopies, said Natsu Tsunaga. Plastic pollution is detrimental to tree functioning, causing oxidative stress and reducing the efficiency of photosynthesis. Because of this, some of the solar energy is no longer used to create nutrients, and excess light can damage plants, almost like burning them. To protect themselves, trees activate photoprotection mechanisms, dissipating excess light as heat.